Chapter 10, Measure Figures, Lesson 5, Volume and Surface Area of Composite Figures. The essential question for the chapter: how do measurements help you to describe real-world objects? We're on the last lesson of the chapter, Lesson 5, and we have two objectives: to find the volume of a composite figure and to find the surface area of a composite figure. Now, instead of finding the volume of a composite figure, we're going to find the surface area of a composite figure. And we find the surface area of a composite figure by finding the areas of the faces that make up the composite figure. Here, though, we have to be a little bit more careful. Sometimes students will include more faces than you're supposed to. Now, we're going to find the surface area of the figure. And this is where we have to really organize our work, and we might have to be a little creative. You might be tempted to break this into two composite solids and find the surface area of each individual solid and add it together. But that's going to give you the wrong answer, and I'm going to show you why. I'm in SketchUp and I made a solid similar to the one in the problem. Now here's what the problem is. You might want to separate this into two separate objects. Here we go over here, and find the surface area of each individual object separately and then add the two numbers. But that's going to be a problem because you're going to be adding more area than you should. And here's why. I'm going to zoom in on this. Get my orbit tool. Now you see the top surface of this rectangular prism? Well, that doesn't really exist. That's not really a surface. Because if you look at the other object here, let's zoom in a little bit, it's not really exposed. You don't actually get to see that, so that doesn't count. Also, when you look at the top part of this, this area here is not going to count either, again because it's glued to the bottom. So anything in between these two pieces are not exposed to the surface. So you're going to be counting it more. So we need another way to organize our work. Let's use wooden blocks again to help us visualize this. When finding volume, you can decompose the two solids and find the volume of each one separately. But that doesn't work when doing surface area. You can't decompose the two solids and find the surface area of each solid. The reason is because you would be counting too much. See that Velcro part? That would be counting more surface area. So we got to do it a different way. You can see that when they're put back together again, they're not part of the surfaces. What I'm going to try to do is brainstorm, because you can do this problem in lots of different ways. Right now I see that I have this face over here and it looks sort of like an L upside down. Let me just outline it to make it easier to see. So that's what I'm looking for, and I'm going to draw that over here and draw a rough sketch. I'll do it in red. And it's just a rough sketch, so it's not going to be perfect. You don't need it to be. Again, though, you should use pencil. Right, so now I have that face there. Now, if you can, you always try to look for copies that are the same. And I notice this face is an exact copy on the opposite side. If you look at SketchUp, here's the face that I had drawn. But if I turn it to the opposite side, you'll notice that it's going to be the same exact amount of space. So once I find out the area to the front, I can just double it. So once I find out this answer, I'm going to double it. Let me put my numbers in before I forget to do them later. So that's 16. So that's 16. That's 16 across. That's 8 across. This distance, they don't tell you directly, but you can figure it out. You know the whole distance is 16. Part of the distance is 8, so this distance must be 8. They don't tell me this distance directly, but I can figure it out. I know the whole distance across is 16. I know this distance is 8, so what must be left is 8. So now I got this. And once I find the area of this, I'm going to double it since I have two faces that are congruent. Now I'm going to go to the next one. Let me erase this so we don't get confused. And I'm going to do this one in green. And I see that I have a 16 by 6, not by 8. You might be tempted to use the number that's near it, but remember this 8 is referring to the length of this edge. I need the length of this edge, which is equal to this. So if it's 6 down there, it's 6 up here. So what I really have is a 16 by 6 rectangle. So I'm going to draw that. Now I'm hoping I can find another side, another face that has the same exact amount. I look over here and I see that it's a 16, and I'm hoping it's going to be 6 across. And again, I do know it's 6 across here on this edge. So this edge is the same as the back edge, so I know that that's 6. So I know this definitely, I can double this. And if you look at SketchUp, here's how it would look. Right now, when I had drawn the figure, I had drawn a sketch of this rectangle. But then I noticed by looking at the numbers that this also was a 16 by 6. So once I find the area of this, I'm going to double it to get the area of that. Now I'm ready to see if I can find another unique face. First, let me erase this so we don't get confused. I see I have an 8 by 6. I'm going to choose a third color. Let's see, I'll do this one. So I'm kind of doing it in blue. I get my rectangle, and I'm doing it in blue. And I notice that it's an 8 by 6. Now I'm hoping I can find other 8 by 6 in this solid. So that's an 8 by 6. And if I look at the bottom of this, right now this is what I'm trying to look at, I'll notice that it's 6 this way, and it is also 8 this way. So I found the second one of the 8 by 6s. Let's see if this one's the third one. I look at this one. Again, I know that it's 8 high, and it's 6 across. So I found 3 of them. And then let's look at the bottom of this. Now the bottom of that would be this. Now I'm looking at this. And I notice that it's 8 by this way and 6 by that way. So there are 4 of the blue ones. So I have 4 blues of this particular size. I have 2 green rectangles of this particular size, and I have 2 reds of that particular size. So now I've accounted for all the faces. So I'm going to get the area of each one, and then I'm going to double this one, double that one, and quadruple that one to find the surface area of everything all together. Alright, let's find the surface area. I'm going to call it S1 instead of SA. I don't want too many letters. So I'm going to find the surface area of this. I'm going to slice this up into 2 rectangles. Now I notice over here I have a 16 by 8 rectangle. So that's 16 times 8. And I have another rectangle here. Now this one is 8. Now how high is it? Well, I know the total distance is 16. This part's 8, so there's 8 left to be here. So I know that that's 8. So that area of that rectangle, or square now that I know that it's a square, is 8 times 8. This is going to give me 128 plus 64. Add those 2 numbers together, and you're going to get 192. Now I'm going to get the area of the green one. Again, it's a rectangle, so it's 16 times 6. So S2 is equal to 96. Now I'm going to do the same thing for the third one. That's S3, surface area of the third object. Again, it's a rectangle, so it's 8 times 6. So S3 is 48. Now we're not done yet, because remember, we have 2 of the S1s, 2 of the greens, and 4 of the blues. So the total surface area, now I am going to write SA, is equal to 2 times 192, because there were 2 of these, plus 2 times 96, because there were 2 of these, plus, now there are 4 of these, so this one's going to be 4 times 48. To save time, I wrote down the numbers quickly, so these are the results. And when you add these 3 numbers, you get 768. Now look for the units of measurement. It's in inches. We're doing inches, but we're not doing cube now because we're not talking about volume. We're talking about surface area. So we put inches squared. Now again, the problem didn't have to be done like this. There are so many different ways you can attack the problem and decompose the figure. It's up to you. Just make sure you keep your work organized so you don't miss a piece or add too many pieces. When you do problems like this, you always try to find faces that are congruent, because that will make your life easier. Because once you find the area of one particular size, and if you know there's a copy, you can multiply it by 2. If you know there are 3 copies, you can multiply that by 3. So always look for the same size surface if you can. So right now, I'm looking at this face here, and I notice it's an 8 by 8. So I have an 8 by 8. I'm going to draw a rectangle, and I'm going to be a little bit more of a sketch here. I'm not going to use the rectangle tool. And I have an 8 by 8. Now, I'm going to see if I have any other 8 by 8s. I see that's 8. Oh, and it's also 8 tall there. So I got a second one. That's great. I also noticed that the back is also an 8 by 8. Let me erase this so you can see it better. And I see I have an 8 by 8 here. So that's good. And I have another 8 by 8 here. So that's perfect. And then, let's not forget the bottom of this also is an 8 by 8. So if you notice, this bottom here is also an 8 by 8. Wow, so I have 5 8 by 8 rectangles. Hey, do I include this one here on the top? And the answer is no, you don't. And let's look at why. Now here was the rectangle that I had outlined in the other file. The reason why you don't count that one is because it's not a surface. It's actually inside the solid. Let's use the wooden blocks again. Here we have a similar solid to the problem. And again, if we decompose it, yes, we can find the volume of the 2 blocks separately and add them together. But when we do surface area, we have to be careful. We can't just decompose them, because then we would be finding too much surface area, including the Velcro part. So we have to do it a different way. So no, you wouldn't count that. So I'm going to erase that. But I do know now that I have 5 of this particular size. I'm going to circle 5, just remember to remind myself to have 5 of that size. Now the next one I see is this triangle. So I got that there, there, and here. So I'm going to make a copy of it. And again, it doesn't have to be a beautiful picture, a real quick sketch. Now I need to know that length. That would correspond with here. It doesn't tell me the length there, but I know that this edge is the same length as this edge. And since that's 8, that's 8. Now I need to know the height of the triangle. Now remember, we have to use the slanted height, and it does tell us that the length from the vertex to the bottom is 6.4. So I know that the height is 6.4. And I notice that this is 8 and it's also 6.4. And actually all 4 rectangles are congruent to each other. So now I know I have 4 of these. So this is great. A lot less work. 5 of this size, 4 of this size, add it together, and I'm done. So right now I'm going to find the surface area of the rectangle, which is 8 times 8, because that's the area formula for a rectangle, which is 64. Then for the green one, I'm going to use the area formula for a triangle, which is 1/2 times its base, which is, in this case, 8, times its height, which is 6.4. Which gives us 25.6. Now I'm ready to find the surface area of everything. So I'm going to write SA. This time I'll write the whole thing SA. Now, how many of the 64s do I have? 5. So I'm going to do 5 times 64. Plus, how many of the triangles do I have of that particular size? 4 times 25.6. SA for surface area. And then you do 5 times 64, which gives us 320. And you always have to show your work. And then you're going to do 4 times 25.6. And you're going to get 102.4. And then you're going to add these two numbers together. Again, always use your calculator to make it less work if you can. You're going to get 422.4. Look for the unit of measurement, which in this case is feet. Remember that it's surface area, so it's going to be feet squared. Now again, you can do this problem in different ways and decompose it whatever way you want. This is just one way, but just keep your work organized and keep track of the numbers. Try this problem on your own. Remember, decompose the problem in any way you want. Make sure your work is organized, and that's it.